Hey guys, so we just completed the topic of DHCP. Now, in the next set of videos, we'll be covering DNS, that is Domain Name System. Alright, so this is the very beginning. Today, we'll be discussing what DNS is and what is the need of DNS. So, let's start right away. Alright, guys, so we'll be starting with DNS, right? We'll be covering DNS. That is an acronym for Domain Name System. Okay, so to understand DNS, first of all, we need to understand the need for DNS. Okay, why did we introduce the concept of DNS? All right, so first of all, we'll be discussing the need part, right? Okay, so as humans, we interact through names, right? You have a name, I have a name, that's how we get identified. So if I want to talk to some person, I'll just call them by their name and I can communicate with them, right? So we interact through names. Now, this interaction is not only limited to our regular world, but even in internet, we use name for communication. For example, I want to use Google, right? Let's say. So I'll have to type google.com and I'll reach there. Okay, but I want to visit pepcoding site, right? So I will just write pepcoding.com and that's it. I'm there. Okay, so what we are doing here is we're using the names. We are using the names. Okay, so this is what we do. This is how we interact as humans. Okay, now behind the scene, we're using TCP/IP, right? We're using TCP/IP protocol, and for that we need something called IP address. IP address that uniquely identifies the connection of a host to internet. Okay, so what happens is that this is our network, this is internet, right? And our host is connected to this network, and the connection is uniquely identified using an IP address. Okay, IP address. So if I tell in simpler terms, this google.com will have some corresponding numeric value, and that numeric value can also be called IP address. Okay, this can also be known as IP address. All right. So now what's happening is we are using names and TCP/IP uses IP addresses behind the scene. Okay, so this situation is pretty similar to, let's say there are two people, A and B. A speaks only English and B speaks only Spanish. Okay, now they do not know each other's language. So for them to have an effective communication, we need to introduce a translator in between that can convert English to Spanish and vice versa. Okay, similarly, we're talking in terms of names here and addresses here. So we need a translator in between. Now the job of the translator would be to provide a mapping of names and addresses. Okay. So we can convert name to address and vice versa, right? So we need a translator of this sort. Now this translation was before, in the earlier times of internet, was ensured using host file. Okay, so host file had only two fields, name and address, right? Only two fields were present, names and address. This is what we wanted to map, right? So this host file, since we are talking about a time when internet was way smaller than it is now, so this host file was limited. Okay, this was a small file. So this file was present or stored in disk of every system. Every system that needs mapping had this file. Okay, and this is how they plotted names to addresses. Okay, and this host file got periodically updated using this thing called master host file. Okay, master host file. So this is now master host file. It is similar to host file. It's a host file, right? But a host file that has global access. So anyone in the world can access this, right? So what happened was that whenever a new IP address was added, we made that change to this master host file. Okay, and those changes, when a host file periodically checked that are there any new changes that I need to accommodate or reflect, if there were, a host file would also add those changes. Okay, so something like that happened. So this was possible when internet was small, but right now there are millions and millions of addresses. Okay, so the host file would be very big, right? We cannot store it at every system. Hoping that every system can store a file that big is stupid, right? So we came up with two plans. First plan was that let's just keep a centralized file, just a centralized file, right? We do not have to make every system have the host file. Instead, what we can do is we can have a file that everyone in the world can access. Whoever wants to perform some mapping can come here, get the mapping, and just go, right? So we are just keeping one centralized file. The problem with this is there are few problems with this. First of all is traffic. There'll be too much traffic. All the hosts would try to communicate with this particular system, and there'll be too much traffic, right? This is not this is impossible to handle for us. Okay, so first concern was this. Second, that we are relying on one device only. Okay, so if this fails, entire internet fails. Okay, so that is like, this is something that we cannot really implement. Okay, so this idea was not implemented. What other thing can we do? What we can do is we can take this big file, this centralized file, right? And instead of making it a centralized file, we just break it into smaller parts. Okay, and we assign each of those parts to some node. Each of those parts to some node. Okay, and what we do is that whenever a host needs to perform the mapping, what the host can do is they can look for the closest computer that has some information. Okay, so whenever they find the closest computer, they'll perform the mapping from there. Okay, so this helped in multiple ways. First of all, we're not just relying on one thing, right? We're not relying on one computer, we are relying on multiple systems, right? Second of all, like, the traffic is diverged. So like in the initial approach, we had just one centralized file and we were all querying from that, right? So there was too much traffic at one location. But if we are doing that at multiple locations, at multiple systems, then traffic is diverged. Okay, so the system of taking the file that has name and addresses and breaking them into smaller parts and then storing at different systems is known as DNS system. Okay, so this is our domain name system. Okay, so we'll be studying this in more detail later on. All right, so coming on to namespaces. Okay, so we need to make sure that there's a complete control over binding of name to address. Okay, so we need to make sure that there's a complete control over binding of names to addresses, right? That is, by that what I mean is that if our IP addresses are unique, right? Our IP addresses are unique. So we need to make sure that our names are also unique, right? Only then there'll be a perfect binding. Only then we'll have one-to-one connection, right? Each name would have a corresponding IP address. Okay, so we need to make this sure, right? Now, namespace that provides unique name to each IP address can be organized in two ways. Okay, sorry, it can be organized in two ways. First is flat namespace, right? Second is hierarchical. Okay, so we have two approaches, flat namespace and hierarchical. So in flat namespace, we are just storing name and address. Okay, so we are just storing name and address. Now this name is nothing but a string. Okay, so this is just a string, a bunch of characters which has no meaning whatsoever. Okay, but they're unique. Each of the strings are unique, they're different. Like one string can be, for example, ABCD, other can be ABCE, right? So this common part has no significance. Okay, like if taking more realistic example here, so one name can be fhta.edu, other can be berkeley.edu. Okay, so these are varying. Like this part is same, right? This part is same for both, but this part is varying, thus the entire string is varying, right? So in this manner, we'll have unique strings. Okay, but this won't have any significance. Like this string, this is just a bunch of characters for us. We are not distinguishing between different parts. We are not taking care that these are common, so they should be together or anything like that. Just names are strings and addresses are numbers. Okay, so to avoid ambiguity in this, we need to make sure that we have a centralized system. We need to have a centralized governing system. So like whenever a new string, a new name is to be added, we'll have to check with all the things that are present. So for that, we need a centralized system, right? So this is pointless for us. Again, centralized system that is giving too much load on one system. So we won't be doing that. Instead, we have a hierarchical approach. Okay, so in this, what happens is the name now has significance. Okay, so let's say this is our name. This is entire name. Okay, so out of this, let's say first part is type of organization. Type of organization. Let's say the second part is name of organization, right? Let's say the next part is department of organization, and next, let's say, is the name of the system that we are providing IP to. Okay, let's assume it for now. Okay, so we have a hierarchy of things in this. Okay, hierarchy in the way that, let's say, we can distribute responsibilities, what I'm trying to say. Okay, so in this, we do not need a centralized system. I can say that let's keep a central system that fixes these two fields, number one and number two. Number one and number two are responsibility of central field. Okay, now this department and name, these, let's say we are dropping these responsibilities onto organization itself. Like it's your organization, you decide which department in the system belongs to and what is the name of the system. Okay, this is your responsibility to decide. We are just giving you the type of organization and name of organization. Okay, now this is better. First of all, we're dividing the responsibilities, right? So this is definitely better. Now, why does this work? Because let's say that there's a system that goes by the name comp, right? And it's present in two colleges. Okay, two colleges is present in, right? So what I'm saying is that even though both the colleges named this part same, right? Still the string will vary. Why? Because this part is given by some central system. So I'll say one would be, let's say, fhta.edu. Okay, other would be berkeley.edu, right? So these are the two colleges. These are the names of two colleges. Now system's name is comp, right? So I'll simply add that. So one will become comp.fhta.edu. Other will become comp.berkeley.edu. Okay, berkeley.edu. Okay. Yeah, okay. So even though the name is same, this part is same, right? Which they were choosing independently. The colleges were choosing for their for their particular organization. This part is common. Still, the strings would vary because this part is chosen by the central organization, and this would always vary, right? So in this manner, we can make sure that the names would be unique every time, right? So hierarchical is implemented using DNS. It is implementing using domain name space. Okay, so next up we'll be discussing what is a domain namespace. All right.